Alright, guys, it's me again, Mr. Matsilele, your FIT lecture. On our previous lecture, I told you that now we are going to do the conversion. On our lecture notes, I'll show you that we have a number system which is binary, octal, decimal, and hexadecimal. And I told you that binary is of base 2, octal is base 8, decimal is base 10, and hexadecimal is base 16. So now I'm going to show you how to convert from decimal to binary, from decimal to octal, from decimal to hexadecimal, also from binary to octal to decimal and hexal, vice versa. We're going to just do the conversion now. We're just going to do the conversion. So let's start with the decimal number system. Just a revision to remind you of the characteristics of decimal number. We say a decimal number system is a number system which is a positional number system, and it has 10 symbols or 10 digits, which is 0, 1 up to 9, and the maximum value is 9. Still remember. So now I'm just going to show you how to convert a decimal number to binary. So let's say, for example, we have this question. Let me just have a question here for you. Let's say we have this question. I'll try by all means to make it big a little bit so that everyone can be able to see. Let's say, for example, we have this question. Okay, let's say it's convert 164 decimal number to its equivalent, and then I say, let's say this is a question, let's say it's question 1, and I say to its equivalence number A, let's say number A, I say to its equivalence, we start by binary number, and then we say B, and then we say number B, we say octal number, and then we say number C, hexadecimal number. Okay, guys, let's say, for example, I give you this question. I hope everyone can see now. The question says convert 164 decimal number to its equivalent binary number, octal number, and hexadecimal number. So now I'm just going to show you how to convert 164 decimal number to its equivalent binary number, octal number, and hexadecimal number. So let's start answering from question 1A. Question 1A. Question 1A. Remember the question says convert 164 decimal number to its equivalent: A, binary number; B, octal number; and hexadecimal number. So now let's just work on each one by one. Okay, so now I'm just going to write it here underneath. Try by all means to make it. So now we are answering question number 1A. We are given 164, which is of base what? 10. And we have to convert it to what? The first one, number A, says to binary. So we want to know what is, and binary is of what? Is of base 2. So we want to know what is the binary number for a decimal number 164. So this is, I'm just going to show you how to do that now quickly. So we're going to do the conversion now, and this is the conversion. If you still remember, we did this one, and I'll give you the example in class where I show you how this conversion was done. The decimal number 45 can be converted to binary by repeatedly dividing the decimal number by 2 until the remainder is 0 or 1. And this is how it is done. At each stage we divide by 2. At each stage we divide by 2, writing down the results and the remainder, which is always either 0 or 1s. And this process stops when we get the result 0. So if we now list the reminders backwards, we get the results in binary format. So now we're going to do it. We're going to do it together. So now we have, this is how you do it. Let me just try to make it simple. So here you are answering this question. It means that you will say we have 164. Let me just change the size. I want it to be big so that everyone will be able to see. So we have 164. We say we divide this 164 by 2, writing the remainder until we get 0. So all the reminders will be writing them on the left. So you can write it this way. You write a line here, and then you write another line here. Write another line here. Then you will say 2 goes how many times to 164? 2 goes how many times to 164? And if you check there, it goes to how many? 82. So it goes 82. You write your 82 here. Does it leave a reminder when 2 goes to 164? Does it leave a reminder? No. So if there's no reminder, is what? Is 0. Then 2 goes how many times to 82? 2 goes how many times to 82? And it goes 41. Does it leave a reminder? No. So if it doesn't leave a reminder there, it's 0. You put 0. Okay, let me just take it up a little bit so that everyone can be able to see. Then we are going down again. Then we say 2 goes how many times to 41? And it goes 20 comma something. So it means that it has the remainder. And we say the remainder is 1. So it goes to 20 and it leaves a reminder there. So 2 goes how many times to 20? It goes 10. Does it leave a reminder? No. 2 goes how many times to 10? it goes 5 times. Does it leave a remainder there? No. So we are continuing. I'll just write it here. Yeah. Then 2 goes how many times to 5? It goes twice. Does this leave a remainder because it's 2 comma something? Yes. 2 goes how many times to 2? It goes okay. 2 goes how many times to 2? It goes 1. Does it leave a remainder? No. And 2 goes how many times to 1? It goes 0 comma something. So we say until we get 0 we will stop. So here the remainder is 0 comma something, the remainder is 1. So now is where you end. And when you write this number, you count them from down. You count them from down. You start writing them from the last number that you write, last digits. Start from down upwards. You start from here going up. So it means that the answer, your answer for this one is starting from down, it's 1 0 1 0 0 1 0 0. We start from down going up, and first digit is 1 0 1 0 0 1 0 0. So therefore we conclude that 164 base 10 is equals to 1 0 1 0 0 1 0 0 base 2. So this is your answer. So that's your answer. So you answered number A. Number A is done. So on our question, let's go back to our question. Then it says, and also to its equivalent octal number. Okay? So now we're going to answer number B. 1.1b. Then 1.1b. Number B, it says 164 base 10. We want to get its equivalent base 8, which is octal. So this one is simple, guys. I'm going to show you again from our lecture notes so that when you study there in your homes, you will remember the place where we get these things. So now we are done with the first conversion, and then converting binary number to its equivalent octal number. We divide the digits into group of 3 starting from the right. Then after we convert each group, I'm here, I'm in this part. Divide the digits into group of 3 starting from the right. Then secondly, convert each group of 3 binary digits to 1 octal digit using the method of binary to decimal conversion. We divide the digits into group of 3 starting from the right. So now let's just go to our question there. From Okay. From this one, when we convert 164 to binary, we get 101000100. So the rule says we must, if you want to convert the binary number to its equivalent octal number, we have to divide the digits into group of 3, starting from the right. So it's simple. If you want to convert this 164 base 10 to 8, first of all, you must first convert it to a binary number. Then from binary number, it will be easy for you to group them into 3. Then you get the octal. So this one, we're going to answer this one now. Okay, let me just wrap this one. Okay, and then I will do this. Just want everyone to see. I just want everyone to see. I just want everyone to see. So if you still remember, the answer for 164 base 10 to its equivalent binary number was 1 0 1 0 0 1 0 0. If you still remember, we'll show you the up. This is 1 0 1 0 0 1 0 0. Then okay, then we have this, we have this, we have this. So let's again remember, this one is of base 2. It's of base 2. 164 base 10 is equals to 101000100 base 2. We did it when we do the first conversion. And here the rule says you must, if you want to convert this binary number to its equivalent octal, divide the digits in groups of 3 starting from the right. Then after you convert each group of 3 binary digits to 1 octal digits using the method of binary to decimal conversion. So let's just do it. First, we must group these binary digits. We must group them in groups of 3 starting from the right. Remember this. Divide the digits into groups of 3 starting from the right. Remember always to divide this one into groups of 3 starting from the right. So now we are going to do the grouping. We group this one 3, and the other one is 3. So this one, because there are 2, what you have to do now, you add another 0 here. You add another 0. You add another 0. That 0, it won't have any effect in your number. It's just that so that at least there will be 3 3. It won't be having any effect. But remember, if you start grouping from left to right, you were going to add another 0, and it was going to be incorrect. It was going to be incorrect because the number number of digits they were going to increase. They were going to increase. So now, if you start from right to left, this 0, it won't have any effect. So now, okay, I was just using which color I was using? It's this one. So now, after grouping all of them, it says we must convert each group of 3 binary digits to 1 octal digit using the method of binary to decimal conversion. So now this is what we are going to do. This is what we are going to do now. So we are continuing. So each group now, the first group is 0, 1, 0. And the second group is 1, 0, 0. And the third group is 1, 0, 0. So converting this 0, 1, 0 using the method of binary to decimal conversion. You still remember? Okay, if you don't remember, don't worry. I'm just going to show you now. Let me just change the color. We say this one, it will be, the first one to be 2 to the power 0, and the other one to be 2 to the power 1, and this one will be 2 to the power 2. We are just using the method of binary to decimal conversion. Then 0 multiplied by 2 to the power 0 is 0. Any number multiplied by 0 is 0. So from this one we have 0. Okay. So that you will see where I am in. Let me just highlight. So I don't want to just say it and you don't see. So from this point, the first one is this part. 0 multiplied by 2 to the power 0 is 0, plus 1 multiplied by 2 to the power 1. 2 to the power 1 is what? Is 2. The last part is 0. Then you leave it. So it means that here the answer is 0 plus 2 plus 0. You still remember, I'm sure that you still remember how to convert from binary to digits. So here we have what? We have the answer for this one is 2. For this one is 2. And the same applies to this second group. You will say 0 multiplied by 2 to the power 0 is what? Is 0. And the 0 multiplied by 2 to the power 1 is 0. Any number multiplied by 0 is 0. And the last one is 1 multiplied by 2 to the power 2, which is 4. So it means that here is 4. And because these ones are the same, so it means that even this one is 4. So we conclude that our final answer is what? Let's check. The final answer is 2, 4, 4. This is the final answer, base 8. So therefore, we conclude that 164 base 10 is equals to 164 base 10 equals to 2, 4, 4 base 8. This is the answer. So I hope you are getting it, guys. I hope you are getting it, guys. Let me just take it slowly. Take it slowly so that all of you understand. You understand? We say 164 base 10, we want to convert it to base 8. Okay, first of all, let's just go again to the question so that at least you understand everything. I don't want you to miss anything. It says convert 164 decimal number to its equivalent binary number. And we did the binary number, and I show you how to convert the binary number. We get that binary number. Then after we want to get the octal, we get the binary number, which is 10100100. So converting to octal, we group those binary number into, we divide those binary digits into groups of 3. Starting from the right, we did it from the right. Then in each group, we will convert it using the method of what? Binary number to decimal. So this is the first group. If you check, let me just show you. Okay. If you see, this is the first group here. This first group here, I think, yeah. This first group here, it gives us what? It gives us 2. Ne? And the second group here, which is this one, it gives us what? It gives us 4. So they are just in a sequence. And then the other group here, which is this one, they give us what? 4. So that is why when you write, because they are just in a sequence, that is why when you write, we say 2, 4, 4 is 8. I hope you all understand. So now let's just do the last part. Let's just do the last part. Let's just do the last part now. Because from the question it says you must also convert it to a hexadecimal number. So we're going to do hexadecimal number. Hexadecimal number. It's number C, you know? Number C, we have 164 base 10, and we say what is the hexadecimal number for this? Hexadecimal number for this, and from previous answer that we have given, I know that 164 base 10 is equals to 10100100 base 2. You remember that? So let's just go to the rows. How do we convert this 164 base 10 to base 16? Okay, the answer is there. I'm just going to show you from the lecture notes, because the reason why I'm referring to lecture notes is that when you study, you will know where we get it, so that it will also help you. It will also help you. So let's just go to, okay, yeah. This is the part. This is the part. So if you want to, okay, converting binary number to its equivalent. Okay, let's start from here. Converting binary number to its equivalent hexadecimal. First, we do what? Divide the binary digits into groups of 4, starting from the right. Then secondly, you combine each group of 4 binary digits to 1 hexadecimal digits. It's the same applies to octal, but now here the difference is that for a hexadecimal, you divide them into groups of 4. So let's just do it now. Let's just go to our answer here. Okay, it says what? Group them, divide each digit into groups of 4. So now we're going to group them into 4. Then after we do the conversion of binary to decimal. So let's check the group. Starting from the right, we'll group them in 4. Then here is this one until here. Then there are 4. And this one at least, you see now we have 2 groups. So each group now we are going to convert it using binary to decimal conversion. So the first group we have 1 0 1 0, and the second group we have 0 1 0 0. So then I'm sure that by now you know how to convert from binary to decimal. How do we do it? Again, let me just show you. Don't want to assume, but I'll make sure that you all understand what we are doing. This one is 2 to the power 0, 2 to the power 1, 2 to the power 2, and 2 to the power 3. Then 0 multiplied by 2 to the power 0, any number multiplied by 0 is 0. And then we are on this part. This one 0 plus 1 multiplied by 2 to the power 1 is what? 1 multiplied by 2 to the power 1 is 2. So on this one we have 2, and here we will have 0, and the last one, because it's 1, we will have what? 1 multiplied by 2 to the power 3 is 8. So it means that it's 8 plus 2, which is what? 10. So here the answer is 10. Oh, sorry guys. It's the work of technology. So it means that on this part we have is 10, and to this one again you do the same. 0 multiplied by now is 0, and the other 0 it will be 0, and this one will be 1 multiplied by 2 to the power 2, which is 4. So it means that here we have 4, and this one is of base 10. Is when we convert it to base 10, and here is when we convert it to base 10. Remember. So when you write it, I told you, let's just go again to this so that you understand something. Okay, you will understand something. So this one, before I go there, it means that from this grouping we have the answer for this one. It will be what? A4. It's A4. I'm going to show you how we get this A4. Here we're saying 164 base 10 is equals to, I'm just writing this way, equals to A4. Why do we write A4? Why do we write A4? Why do we write A4 instead of saying the answer is 10 4? But we say this is wrong. We say this is wrong. It's not 10 4. It's A4. Why are we saying it's A4? So now let's just go. I'm just going to show you why are we saying that this one is A4. Remember the numbering system. Hexadecimal, the digits start from 0. When it goes to 9, after 9, the 10 is represented by A, 11 by B, so on and so on. So that is why now here we have what? We have A4. I hope you understand everything and you will be able to do all these things. So now, from this question, we understand that from this question we understand that 164 base 10 is equals to what? We get the binary, which is 1 0 0 1 0 1. If you still remember, it's 1 0 1 0 0 1 0 0 base 2. So it's answer number A. Number B we get that this octal number is its equivalent octal is what? If you still remember, it's 244. Yeah, it's 244 base what? 8. And then hexadecimal, it's what? Hexadecimal will go to what? A4. I'm sure that you all remember that this is the last part that we did. So we are done with the conversion. So we got that this 164, which is of base 10, is equivalent to it's equivalent to 101001 base 2 and is equivalent to 10100100 base 2 and is also equivalent to 244 base 8, and lastly its hexadecimal is A4. Then you are done with the conversion. Thank you very much for watching. We are going